So people asked me yesterday, do we really need to rewrite all of this? And I would say for these dilations, I would say definitely. Because we want to know what our new ordered pair is. And it's really hard, like with the translations, it was really easy to count. Left 3, down 4, and do whatever we needed to do to it to get to its new location. And translations really are counting. I can't really do that with P. I can't say, let's take P and multiply it by 4, then where does it end up at, right? So coming up with the new ordered pair is really important for all 3 of those points. And one thing that really gets messed up probably is if I plot these wrong, or sometimes what will happen is sometimes we'll only multiply one of the numbers by 4 and we'll forget to do the other one. You just got to make sure you're really careful of all the numbers in the math that you do. So if we multiply by a scale factor of 4, what this should do is this should make my new figure 4 times bigger, okay? So we're going to multiply everything by 4. Just be careful if I have 0, 0 times anything, it's still 0. So that is the one thing that's not going to change when we multiply by a number. Those are my 3 new ordered pairs. And then R prime. Sometimes there'll be a little overlap maybe with some of these. Sometimes there won't be. It just kind of depends on what you've got and where you're going. But what would be a way for me to check to see if this really is 4 times bigger? What did we talk about yesterday? Let's count the sides. What side would be the best to count or easiest to count? The bottom, right? Because it's horizontal. I don't want to count a side, or I really can't count a side that is slanted or has slope to it. I would have to use the distance formula, and we don't really want to do that. So if I have a side that is either horizontal or vertical, that would be the one I would use. The original one is 2. That one's pretty easy to count, right? And then from P prime to R prime is 1, 2, 3, 4, 5, 6, 7, 8. And so we just want to verify that this side is 4 times bigger than that side, which it is. And so that tells us that everything looks good, okay? We can't necessarily do all sides, but if you pick one side, then you kind of hope that if I did one side right, I did all 3 sides right. Okay. Questions on doing that dilation, that scale factor of 4? Okay. On this one here, yesterday we talked about where we use a dilation is a lot of times with photographs, but there's other places that we might use it as well. But in this case, we have this picture, and we're trying to make some stickers of this picture that we want to use or whatever. The original photo is 4 by 4. So this is my original. The image of the stickers is a 1 by 1, or 1.1 by 1.1. Okay, and the one thing that must be true is if these 2 sides are the same, these 2 sides have to be the same, because we're applying the same rule to it, okay? Now this is not just an easy multiply or divide by 4, because it's a decimal, right? And so here, what we said yesterday was C to P prime over C to P, right? But we don't have a C to P prime in this case. But what that tells us, anything with the prime notation on it is the new, and C to P is the original. So the new is always going to go on top, the original is always going to go on bottom. So you really have to be careful about which one did we start with, which one are we adding to it or changing. So my new is the 1.1 side. The original is 4. Okay. Now this one, it's not really hard to determine what goes with what because the 2 sides are the same, right? 1.1 goes to 4, 1.1 goes to 4, they're the same thing, so it doesn't really matter which one's which. If we have two different sides, let's say it's a rectangle and one side's 4 by 8, and then I have another smaller rectangle, then I got to decide which one goes with which. And we'll talk about how to do that here in just a minute. Okay? If I wanted to come up with a ratio, a scale factor here, a scale factor cannot have a decimal in it. So I cannot leave it like this. I can't say 1.1 over 4. We never want to put a decimal in a fraction. We never want to put a fraction in a fraction. So I don't want to say like 1/2 over 3. That's not an appropriate way to write a fraction. So we never want to leave a fraction with a decimal or a fraction in it. So how would I get rid of the decimal in this case? How do I read this number? What number is this number? It's 1.1. What place value is this right here? It's the tenths, okay? I want to get that decimal out of there. So if I have a number that's in the tenths place, how would I move that decimal over so the decimal's not there anymore? Not right now. What do I need to do to move that decimal over? Anybody remember? Moving decimals?
Multiply by 10.
Multiply by 10. That's exactly right. Okay? Multiplying by 10 makes me move that decimal. Okay? Because everything is a place value. Place value of 10. Tenths, hundredths, thousandths. We're talking about place values of 10, so we just multiply by 10. But if I do it to the top, I got to do it to the bottom. And so my scale factor here would be 11 over 40. Okay? So on a quiz or a test, if you were to write 1.1 over 4, you're going to miss it. Okay? Because that's not how we write a decimal or a fraction. We would have to write it with all integers or whole numbers, no decimals. Okay? Here's another scenario where you might see something that you might have actually heard this, right? We're talking about dilations here. An optometrist dilates the pupils of a patient's eyes. If you've ever gone to the eye doctor, he might say, I'm going to dilate your pupils so that he can get a better idea. And what that does is it makes them bigger so that he can get a better look at the back of your eyes. The pupil dilates from 4.5 millimeters to 8 millimeters. What is the scale factor of this dilation? So here is what it was originally. Here is the new size of the pupil. So we're always going to go new over original. So we want to identify which one's which. So we know which one goes on top, which one goes on bottom. Okay. Plus, my pupils here are getting bigger, right? So the bigger number should be on top because that's an enlargement, not a reduction. And those are the things that you got to think about when we write this. Because it's really easy which one goes where, okay? If I put 4.5 on top, that means we're getting smaller, and that's not what's happening here. So that's where you got to be really careful, okay? Once again, I have a decimal, right? I don't want to leave that decimal alone. So what am I going to have to do? Multiply by 10. Okay, so if we multiply by 10, we have 80 over 45. But what do I always got to do when I simplify or leave a fraction? Yep, got to put it in simplest form. Okay, so I got to find something that goes into both 80 and 45 here. 5. And so this would be 16 over 9. And that would be my scale factor. A scale factor is, yesterday, the scale factors that we saw were mostly nice whole numbers. 3, 4, 2. When we did a reduction, it was like 1/2. It was nice, easy numbers to work with for the most part. When we look at problems like this, where we're looking at an actual scenario of something being dilated or reduced or enlarged, then my scale factor may not be a nice whole number like 2. Okay, so 16 over 9 is our answer here. Okay, we got this spider, and we're looking at a magnifying glass that shows the image of this object 6 times the actual size. So when I look at it under the magnifying glass, then it's going to make it bigger so I can see things a little bit better, right? Determine the length of the image of the spider seen through the magnifying glass. Image over the actual. Okay, image is my new, actual is what it was to start with, or the actual size of it, okay? When I look at it under the magnifying glass, then it is 6 times bigger. So here's what we're going to do. What I would recommend doing on this one is setting up a proportion. I'm trying to figure out what the size of the spider is going to be under the magnifying glass. Originally it's 1.5 centimeters long. And we know that it is 6 times bigger. So I'm going to say 6 over 1. So writing my scale factor there is pretty easy. But proportion here is the way to go, especially if my scale factor is a number like 16 over 9, right? I know on this one, most of you would say, I can just multiply by 6, it's a piece of cake. But what if your scale factor is 16 over 9? Then you can't just multiply it by a single number, right? So that's why setting up a proportion is going to be very helpful on ones like this. And so then if I cross multiply, it's been a while since we've solved a proportion, but we're going to solve a lot of proportions this year as we go throughout. We're just going to take 6 times 1.5. And it would be 9 centimeters. So when I look at it under the magnifying glass, the spider is going to look like it's 9 centimeters long. Make sure your answer makes sense. It should be bigger, right? We're blowing it up. We want to see it a little bit better. Okay, on this one here, we're using a magnifying glass that shows the image of an object as 6 times the object's actual size. Find the actual length of the spider. Okay, so on this one here, we actually have the magnifying glass placed over the top of it. So when we have it placed over the top of it, we're saying the magnified length of it is 12.6. And we don't know the original, right? The new over, and once again, I'm going to write this, the image over the actual. The actual is the actual size of the spider in this case. The image is what we get when we look at it underneath the magnifying glass. So we got to be careful about what goes where. Okay, this one, once again, it's 6 times bigger, so it's still 6 over 1. So as we cross multiply here, we're going to take 6 times x. 12.6 times 1 is simply just 12.6. And then we can take 12.6 divided by 6. And we get 2.1. I think the hardest part to this one is just reading through it, and are they giving me the blown up or the new length, or are they giving me the original length of the spider? So you got to really read it carefully. May not always be a picture provided like we have here. It'd be nice if there's always a picture, but not always. Okay. Find x. Okay, find x down here. They're giving me the length of the whole thing. They're also giving me dimensions of the 2 triangles. Okay, C is our point of dilation. Yesterday, like when we did it on coordinate plane, 0, 0 was our point of dilation. So when we talk about the big figure, okay, the big figure, to get from C to the bigger figure, the red figure, is 35 units long, right? But let's first of all go to the 2 sides that we know. The blue figure has a side of 9, the red figure has a side of 15. Okay, now there's a couple different ways that you could set this up. I could set it up as 9 over 15, or 15 over 9, okay? Does it matter which way I set that up? No, okay? You could go 9 over 15, 15 over 9. In this case, it really doesn't matter which way you go because we don't really know what the scale factor is. And we're not necessarily going to find the scale factor. We're just looking for x, right? What's the length of the distance from C to that? Do I need to reduce 9 over 15? I mean, we could, but do we have to? Not necessarily. Just means we're going to deal with a little bit bigger numbers is the only thing that it means. So do you have to? Not in this case here, but if you did, it would be okay. Okay, so now we have to decide. We have x that we're trying to find, and we have 35 that we're given. Where do you think 35 is going to go? Is it going to go on top with the 9, or is it going to go on bottom with the 15? It's going to go on bottom, right? Because 15 is the bigger one, and 35 is going to the bigger side, right? Or the bigger triangle. And so 35 is going to go out to the bigger side. So 35's got to go here. And then the shorter one, what we're trying to find here is what's that length right there? How far are we getting out to get to that smaller triangle? So that would be x. So we're going to do 15 times x equals 35 times 9. And then 315 divided by 15. What's that give me? 21. Okay. And what I want to show you here is if I reduce this, I'm going to get the same thing. Okay. This would be 5x equals 105. And then I still get x equals 21. Okay. So on something like this, you wouldn't necessarily have to do it. If I said, what's the scale factor here, then I would want to reduce it. I would want to reduce it to be 3/5 because 3/5 is my scale factor here. And so if I ever ask you what is k, in this case, k is 3/5. Okay? And that could be a question. That sometimes could be asked. But in this case, we were just solving for x, so we didn't necessarily have to find k. So I just wanted, this one probably would be a little bit nicer to multiply because we don't have quite as big of numbers. Okay, and so it might be a little bit easier for you. But if you're just using your calculator, then it really wouldn't matter that much anyway. Okay. All right, that finishes up 4-5 for us. We just didn't have enough time to get through all of that yesterday. On your extra practice, you should have started 4-5 hopefully yesterday. You might have got it all done, but if not, you need to work on that. You can skip number 10 on the extra practice. So on that back page, you just have to do 8, 9, 11, and 12. Number 11 and 12, it's asking for both the scale factor and the missing value. That's what we just talked about. So not only are you finding the missing value, but it also says find the scale factor. So that's why I showed you here just a second ago how to find the scale factor.